Ever bitten into a jalapeno, or perhaps something even spicier? That initial burst of flavor can quickly turn into something else entirely. And felt like your mouth was on fire? A sensation so intense it demands your immediate attention, maybe even a desperate gulp of water or anything to quell the inferno. That burning isn't a flavor, not in the traditional sense. It's not sweet, sour, salty, or bitter. It's a trick played by peppers, a clever and sometimes overwhelming defense mechanism. They've evolved a way to make us think twice about consuming them. The culprit is capsaicin, a fascinating chemical compound. A chemical evolved by peppers over millennia. It's their secret weapon in the battle for survival, to deter mammals from eating their seeds. Because mammals, unlike birds, tend to grind up the seeds, preventing them from germinating and spreading. Capsaicin binds to TRPV1 receptors in your mouth. These receptors are like tiny sensors. The same ones that sense real heat, the kind you feel when you touch a hot stove or sip boiling water. Fooling your brain into thinking you've touched something scalding. It's a complete sensory illusion, a masterful act of deception by the pepper. Your body reacts as if it's in danger, even though there's no actual tissue damage. Pain, sweating, your body's natural cooling mechanism kicking into high gear, redness and a runny nose. All signs that your body is trying to expel the perceived threat. Milk helps because its fats and proteins, particularly casein, are lipophilic. Wash capsaicin away from those pain receptors. Water, on the other hand, doesn't work as well because capsaicin is an oil-based compound. Since the heat comes from a measurable chemical, capsaicin, and its concentration varies greatly between different peppers, scientists realized they could quantify spiciness. They sought a way to objectively measure the intensity of the burn. This led to a quest to put numbers on the burn, to create a standardized scale that everyone could understand. Starting with brave human tasters, willing to endure the fiery sensation for the sake of science, and a lot of sugar water. Because sometimes, even the bravest tasters need a sweet escape from the heat. In 1912, pharmacist Wilbur Scoville needed a way to measure pepper heat for a medicinal ointment. He invented the Scoville organoleptic test, using human tasters to see how much a pepper extract had to be diluted before its heat disappeared. The result, the Scoville scale, measured in Scoville heat units, SHU. Bell peppers rate 0 SHU. Hotter peppers require more dilution and get higher numbers. For the first time, people could compare peppers with a universal language of heat. Scoville's simple idea became the global standard, even as technology advanced. Today, we still use his scale to rank everything from mild poblanos to the world's hottest peppers. The original Scoville test was all about the human tongue. Dried pepper was soaked in alcohol to extract the heat, then mixed with sugar water. A panel of 5 tasters would sip increasingly diluted solutions until most could no longer feel the burn. The number of dilutions needed became the pepper's SHU rating. For example, if it took 5,000 parts sugar water to neutralize the heat, that pepper scored 5,000 SHU. Hotter peppers, like habaneros, needed far more dilution. The method was clever but grueling, relying on human pain tolerance and stamina. Despite its flaws, it defined how we talk about spicy food for a century. Scoville's test was groundbreaking, but it had big problems. Humans are inconsistent. Everyone senses heat differently, so results varied from person to person and place to place. Tasters quickly became desensitized. Palate fatigue set in, making later tests less accurate. The process was slow, labor-intensive, and required rare, reliable tasters. It wasn't practical for large-scale or scientific testing. The food industry needed something faster, cheaper, and more precise. Scientists wanted to remove human subjectivity and find a truly objective way to measure heat. The world was ready for a machine that could taste peppers with perfect accuracy. By the 1980s, technology delivered high-performance liquid chromatography, or HPLC. HPLC doesn't use taste buds. It measures capsaicinoids directly in a pepper sample. Dried ground pepper is extracted with a solvent, then injected into the HPLC machine. The machine separates and quantifies each spicy compound with incredible precision. As each chemical exits the column, a detector measures its concentration. HPLC can identify different capsaicinoids, like capsaicin and dihydrocapsaicin, giving a detailed heat profile. The result is objective, repeatable, and far more accurate than human tasters. It's the modern, robotic tongue Scoville could only dream of. In today's world of culinary exploration and extreme flavors, understanding the heat level of chili peppers is more important than ever. High-performance liquid chromatography, or HPLC, is a sophisticated analytical technique used to precisely measure the concentration of capsaicinoids in a pepper sample. HPLC gives results in parts per million, ppm of capsaicinoids. But despite the precision of modern analytical methods, the world still speaks in Scoville heat units. This is the language of spice, the common tongue understood by chili heads and chefs alike. The Scoville scale provides a relatable and universally recognized metric for gauging the pungency of peppers and the fiery intensity of hot sauces. So how do we bridge the gap between the scientific precision of HPLC and the familiar Scoville scale? Scientists convert ppm to SHU using a simple formula, a mathematical bridge that connects the lab to the lexicon of heat. This conversion allows us to express the capsaicinoid concentration in terms that everyone can understand. The conversion factor is quite straightforward. 1 ppm of capsaicin equals about 16 SHU. This simple ratio allows for easy translation between the scientific measurement and the Scoville rating. It's a crucial step in standardizing the heat levels of peppers and pepper-based products. To put things into perspective, pure capsaicin, the compound responsible for the fiery sensation, is rated at a staggering 16 million SHU, the ultimate benchmark. This represents the absolute peak of pungency, the upper limit of the Scoville scale. It's the yardstick against which all other peppers are measured. For example, let's consider the popular jalapeno pepper. A jalapeno with 375 ppm of capsaicinoids scores 6,000 SHU. This puts it firmly in the mild to medium heat range, making it a versatile ingredient for adding a touch of spice to various dishes. This method, sometimes called Gillette's method, represents a harmonious blend of old and new. It combines lab precision with Scoville's familiar scale, offering a reliable and consistent way to measure and communicate the heat levels of chili peppers. It's a testament to the enduring legacy of Wilbur Scoville's pioneering work. Now, SHU ratings on hot sauce bottles are based on real chemistry, not just brave tongues. This means that consumers can trust the accuracy of the heat levels advertised on their favorite spicy condiments. The Scoville scale has evolved from a subjective assessment to an objective measurement, thanks to the advancements in analytical chemistry. The Scoville scale remains the gold standard, a testament to its enduring relevance and widespread adoption. This is thanks to this blend of tradition and technology, a marriage of sensory evaluation and scientific analysis. It's a system that has stood the test of time, adapting to the evolving landscape of chili pepper research and the growing demand for accurate heat measurements. So, the next time you see a SHU number on a hot sauce bottle or a package of chili peppers, remember that you're looking at science in action. You're witnessing the culmination of decades of research and innovation, all aimed at quantifying the fiery intensity of these fascinating fruits. It's a number that tells a story of heat, flavor, and the enduring quest to understand the power of spice. The Scoville scale reveals the wild range of pepper heat. Bell peppers sit at 0 SHU, no heat at all. Banana peppers and pimentos, 100-900 SHU. Poblanos, 1,000-2,000 SHU. Jalapenos, 2,500-8,000 SHU, the gateway to real spice. Serranos, 10,000-23,000 SHU. Cayenne, 30,000-50,000 SHU. Habaneros, 100,000-350,000 SHU, once the kings of heat. Then came the Superhots, ghost pepper, over 1 million SHU. Trinidad Scorpion and the Carolina Reaper, up to 2.2 million SHU. In 2023, Pepper X set a new record, 2.69 million SHU. At this level, it's not just food, it's extreme science. Not all peppers of the same type are equally hot. It's a common misconception that if you're growing a specific variety, like a jalapeno or a habanero, every single pepper will pack the exact same fiery punch. But the reality is far more nuanced and fascinating. The heat level can vary quite a bit, even within the same batch of peppers, even on the same plant. You might find one pepper that's relatively mild, while another, seemingly identical one right next to it, could bring tears to your eyes. This variability adds an element of surprise and intrigue to the world of peppers. Heat depends on genetics and environment. The genetic makeup of the pepper plant plays a crucial role, determining its potential for capsaicin production, the compound responsible for the burning sensation. But genetics are only part of the story. Soil, sunlight, water, these environmental factors have a profound impact on the pepper's heat level. The type of soil, the amount of sunlight the plant receives, and the availability of water all contribute to the final spiciness of the pepper. And stress all matter. Believe it or not, the amount of stress a pepper plant experiences during its growth can significantly influence the heat of its fruit. Stressed plants often produce hotter peppers. When a pepper plant is under stress, it tends to produce more capsaicin as a defense mechanism. This is why peppers grown in challenging conditions often pack a more significant punch. A habanero grown in the Yucatan sun can can be much spicier than one from a cooler climate. The intense sunlight and warm temperatures of the Yucatan Peninsula create the perfect conditions for habaneros to develop their signature fiery flavor. A habanero grown in a cooler climate, with less intense sunlight, will likely be milder in comparison. The real heat is in the white membrane, placenta, not the seeds. Many people mistakenly believe that the seeds are the source of a pepper's heat, but that's not the case. The capsaicin is concentrated in the placenta, the white spongy tissue that holds the seeds. Removing this tissue is the best way to tame a pepper's fire. If you're looking to reduce the heat of a pepper, carefully removing the placenta will make a significant difference. Ripeness also matters. As peppers mature and change color, their heat usually increases. As a pepper ripens, it continues to produce capsaicin, resulting in a hotter flavor profile. This is why fully ripe, brightly colored peppers are often the spiciest. Every pepper is a unique chemical creation, making the world of spice full of surprises. The complex interplay of genetics, environment, and ripeness creates a vast spectrum of flavors and heat levels within the pepper family. That's why no two bites are ever quite the same. Each pepper is a unique experience, a testament to the power of nature and the fascinating chemistry of spice. So, embrace the variability and enjoy the exciting journey of exploring the world of peppers. Capsaicin is the star, but it's not alone. Peppers contain a family of capsaicinoids. Capsaicin and dihydrocapsaicin make up about 90% of the heat, but each has a different burn profile. Capsaicin delivers a sharp, front-of-the-mouth sting. Dihydrocapsaicin lingers in the throat. Other minor capsaicinoids add subtle differences to each pepper's heat. HPLC can measure each one, giving a full heat fingerprint. Every pepper's burn is a unique chemical symphony, not just a solo act. This diversity is why chili peppers offer such a rich and sometimes surprising, spicy experience.